Welcome back, everybody, to another deep dive. Today, we're going to be doing something pretty interesting. We're diving into the world of solvents, but not just any solvents. We're going beyond your everyday H2O.
That's right. We're looking at cocktail party chemistry, episode 98, Solvent Secrets Beyond H2O in Chemical Reactions. It's a fascinating look at some pretty incredible alternatives to water that are really shaking things up in chemistry.
Yeah, I mean, it's easy to think of water as like the universal solvent, right? Like it's the go-to for pretty much every chemical reaction.
Yeah, it's kind of like that trusty old chef's knife in the kitchen, the one you use for almost everything.
Exactly. But just like in the kitchen, sometimes you need a more specialized tool. So cocktail party chemistry really dives into two of these specialized solvents, ionic liquids and supercritical fluids.
Right, and they both have some really unique properties that make them super useful in certain situations.
So let's start with ionic liquids.
Mm-hmm.
I'll admit I don't know a whole lot about them. What exactly are they?
Well, imagine a salt. That's a liquid at room temperature. That's essentially what an ionic liquid is.
Okay, I can kind of picture that. But how is that even possible?
Mm.
I mean, table salt is definitely not a liquid.
Right. It all comes down to the structure. You see, table salt is a crystal with ions packed together really tightly. But in an ionic liquid, the ions can move around more freely, so they don't form that rigid crystal structure.
So it's like the ions are having a little dance party instead of being stuck in a stiff formation.
Exactly. And this free movement of ions gives ionic liquids some really interesting properties.
Like what?
Well, one of the biggest advantages is their tunability. By tweaking the structure of those ions, chemists can actually fine-tune the properties of the liquid.
You mean like changing how thick or runny it is? Or how well it dissolves other stuff?
Exactly. Things like viscosity and solubility can be adjusted to create like the perfect environment for a specific reaction.
Whoa. That's like having a mixing board for your chemical reactions. You can adjust the levels of each component until you get the perfect blend.
Yeah, that's a great analogy. And this tunability opens up a whole world of possibilities for designing more efficient and sustainable chemical processes.
Speaking of sustainable cocktail party chemistry, also mentions another big plus for ionic liquids. They have low volatility.
Mm.
I think I have a vague idea what volatility is, but can you refresh my memory? And why is it such a big deal?
Sure, volatility is basically how easily a liquid evaporates. So think about a puddle of water drying up in the sun. That's evaporation in action.
Right. Makes sense.
Now, a lot of traditional solvents are highly volatile, meaning they release those vapors into the air really easily.
And that's not great for the environment, right? Not to mention it can be dangerous for the people working with them.
Exactly. But ionic liquids are different. They have very low volatility, so they're much safer to work with and much less likely to pollute.
So less risk for the chemist and a win for the environment, too. That's pretty impressive. But let's move on to those supercritical fluids. They sound kind of mysterious and a little bit sci-fi.
They do have a certain mystique, don't they? They kind of blur the lines between liquids and gases. Imagine you take a substance and heat it up and pressurize it beyond a certain point called its critical point. It enters this weird in-between state where it's not quite a liquid and not quite a gas. That's a supercritical fluid.
Okay, I'm trying to wrap my head around that. So it's like it has superpowers. Can it like walk through walls or something?
Not quite, but it can do some pretty amazing things. It can dissolve things like a liquid, but it can also diffuse through materials like a gas.
So it's like a master of disguise. It can be both a liquid and a gas depending on the situation.
Exactly. And that gives it some really unique advantages in certain applications.
Like what kind of applications?
Well, one classic example is decaffeinating coffee. Traditionally, they use some pretty harsh chemicals to extract the caffeine, but now a lot of companies use supercritical CO2.
Wait, really? Supercritical CO2 is used to decaffeinate coffee.
Yep. It's actually a pretty neat process. The supercritical CO2 penetrates the coffee beans like a gas, dissolves the caffeine, and then it can be easily separated out, leaving the flavor of the coffee intact.
So my morning cup of decaf is all thanks to the magic of supercritical fluids. Just fun fact I'm definitely going to share. But seriously, that's amazing. How else are these supercritical fluids used?
Well, because they're so good at diffusing through materials, scientists are exploring their use in medicine.
Oh, really? Like how?
They're looking at ways to use them to deliver medications directly to specific sites in the body. Imagine being able to target a tumor with a drug without affecting the surrounding healthy tissue.
Wow. That's like pinpoint accuracy. It sounds like something straight out of Star Trek.
It does, doesn't it? And because the properties of a supercritical fluid change with pressure and temperature, you can actually fine-tune its dissolving power too. So you can optimize the whole process.
So you're telling me we could have medicines delivered with the precision of a guided missile, all thanks to these supercritical fluids. That's mind-blowing.
It's pretty amazing stuff. And we've only just scratched the surface of what's possible with these alternative solvents.
It sounds like both ionic liquids and supercritical fluids have some incredible potential, but they also sound pretty high-tech.
Yeah.
I mean, are they actually being used in real-world applications right now?
Oh, absolutely. They're already making a big impact in a number of industries. But before we jump into those examples, I think it's worth taking a step back and looking at the bigger picture. Why are these alternative solvents such a big deal in the world of chemistry? It's all about green chemistry. You know, sometimes it's called sustainable chemistry. It's this whole idea of trying to make chemical processes as environmentally friendly as possible.
Right, green chemistry. I've definitely heard of it. But honestly, I'm not sure I fully understand what it entails. Is it just about, like, using less toxic chemicals or something?
Right. Well, it's more than just that. It's about taking a holistic approach. You know, looking at the entire life cycle of a chemical process, from the raw materials and the energy used to the waste that's generated. The ultimate goal is to design processes that are inherently safer and more sustainable from start to finish.
Okay, so it's about thinking about the big picture and minimizing the environmental impact at every step. And these alternative solvents fit right into that.
Exactly. Take ionic liquids, for example. Their low volatility means there are fewer harmful vapors released into the atmosphere.
Right, we talked about that earlier.
Plus, because they can be designed to dissolve very specific substances, they can often be recycled and reused, which cuts down on waste even further.
So not only are they safer to handle, they also help reduce pollution and waste. It's a win-win-win situation. But what about supercritical fluids? How do they contribute to this whole green chemistry idea?
Supercritical fluids often allow reactions to occur at lower temperatures and pressures than traditional methods, so you end up saving a lot of energy.
Oh, that makes sense. Using less energy means a smaller carbon footprint.
Precisely. And remember that decaffeination example we talked about. Using supercritical CO2 means you can avoid those harsh chemicals that were traditionally used to extract the caffeine.
Right, so less energy consumption and fewer nasty chemicals involved. It's really amazing how these solvents are helping to make chemistry more sustainable. But let's get down to brass tacks. Are there any real-world examples of how these solvents are actually being used today?
Oh, tons. Ionic liquids are making waves in a bunch of different industries. They're even being used in some really advanced batteries.
Batteries, like the ones in our phones and electric cars?
Yep, exactly. Those traditional battery electrolytes can be flammable. You know, they pose some safety risks, but ionic liquids with their low volatility and high thermal stability offer a much safer alternative.
So our gadgets are not only powered up, but they're also safer thanks to ionic liquids. That's pretty cool. What other industries are benefiting from these liquid salts?
Oh, they're also being used in pharmaceuticals to help synthesize drugs more efficiently. You know, imagine being able to create life-saving medications with a smaller environmental impact.
Wow, that's incredible. It's like giving the pharmaceutical industry a green makeover. Okay,
Oh.
so ionic liquids are definitely proving their worth. What about supercritical fluids? Where are they making their mark?
One of the biggest areas for supercritical fluids is in the food industry. Remember how we talked about decaffeinating coffee? Well, they're also used to extract flavors and fragrances from plants.
So they're used to make natural essences without using harsh solvents.
Exactly. You get those beautiful natural flavors and aromas without the environmental burden.
Wow, so my decaf coffee and the vanilla extract in my pantry could both be a result of supercritical fluids.
That's fascinating. It's amazing how something that sounds so high-tech is actually part of our everyday lives.
It is, and their applications go way beyond food. Supercritical fluids are being explored in the pharmaceutical industry too for things like drug formulation and particle size control. So they're helping to create more effective medicines. That's amazing. It seems like there's no limit to the potential of these alternative solvents. What's next on the horizon for this field?
Yeah, it really makes you think about how something as simple as a solvent can have such a huge impact on so many different areas. It's mind-blowing. I mean, we've talked about everything from decaf coffee to life-saving medicines, all thanks to these alternative solvents. What other exciting developments are on the horizon?
Well, what's really fascinating is that these innovations aren't limited to just chemistry. They're starting to make waves in other fields like manufacturing, for example.
Oh, really? Like how?
Well, for instance, supercritical fluids are being used to create these incredibly precise microstructures in materials. It's
Mm.
like sculpting materials at the nanoscale.
Sculpting at the nanoscale. That sounds insanely precise. What are the implications of that kind of control?
Well, it allows us to create materials with properties that were pretty much impossible to achieve before. Like imagine lighter and stronger materials for aerospace, or even more powerful microchips for electronics. So we could be seeing everything from lighter airplanes to more powerful computers thanks to these solvents.
That's pretty incredible. Are there any other areas where these alternative solvents are making a difference?
One area that's particularly exciting is medicine. Researchers are investigating ways to use supercritical fluids to encapsulate drugs and deliver them directly to targeted sites in the body.
So, like, instead of just taking a pill that circulates throughout your whole body, you could have a drug delivered directly to a tumor or something.
Exactly. It's like a guided missile for medicine.
Wow, that's incredible. What are the advantages of this approach over traditional methods?
Well, with traditional methods, the drug often circulates throughout the entire body, which can lead to all sorts of unwanted side effects. But this targeted approach could really minimize those side effects because you're delivering the medication precisely where it's needed.
Right, so you're getting more of the good stuff and less of the bad. That's amazing. And what about ionic liquids? Are they being explored for any medical applications? Actually, yeah, they're being investigated for their antimicrobial properties, which could lead to some really interesting new disinfectants and antiseptics.
Huh. So ionic liquids could help us fight germs too. That's pretty
Yeah.
impressive. So we've got alternative solvents tackling pollution, revolutionizing manufacturing, and even improving medicine. It seems like these solvents are real game changers. What does all this mean for us, though? The non-chemists of the world. Why should we care about these advancements?
Well, it means that these innovations have the potential to touch every aspect of our lives, from the products we use every day to the medicines we rely on, even the air we breathe. The advances in solvent chemistry are paving the way for a more sustainable and innovative future.
So by designing these smarter chemical processes, we're creating a better world for everyone.
Exactly. And that's really what it's all about.
Well, this deep dive has been a real eye-opener for me. It's amazing to see the power of these solvents and how they're shaping a more sustainable future. I'm left thinking about how these innovations in chemistry can inspire us to solve problems in other areas of life. It's like a reminder that even the smallest things can have a huge impact, and that by thinking outside the box, we can create a better world for ourselves and for generations to come. Thanks for joining us on this journey beyond H₂O. Until next time, keep exploring, keep learning, and keep asking those big questions.